is the one we didn't get. How do we go backwards from comprehensive?
Okay, it's simply that, and we did this in the chapter 7 notes. If you're going from a lower number to an upper number, X bar was it an X? Yeah, X, it was a mean. If it's a mean, it'll be mu in the middle. X bar is the number right in the middle.
So that's your point estimate.
That's your point estimate.
And how do you find margin of error?
So that's upper plus lower divided by 2.
Gotcha.
Margin of error is this distance here from.
Oh,
Okay?
thank you.
Mm-hmm. We did that at the beginning of the chapter 7. Okay, okay, so this is the sample test, wherever it went. It's very similar to my test. So you should study the chapter 6 notes, the chapter 7 notes. You look back at your D2L quizzes, look back at your worksheets. I post the correct answers to make sure you understand them. So this is from the chapter 6 notes. The standard deviation of the standard normal curve is 1, and the mean of the standard normal curve is 0. That was when we had Z on the horizontal axis. It always looked like this. It had a mean of 0. We made about 3 marks, 1, 2, 3. This is the standard normal curve. And we started out with that, and we found areas under that curve, and we found probabilities. That's areas. And we found z-scores. The z's here are called z-scores. And the empirical rule, which you should memorize, is that 68%, 95%, and 99.7% of all data is between plus or minus 1 standard deviation, plus or minus 2 standard deviations of the mean, and plus or minus 3 standard deviations. So 1, 2, and 3, that's from the chapter 6 note. So what's between plus and minus 2 standard deviations of the mean? 2 is 95. Which of the following is not a property of the normal distribution? The normal distribution is symmetrical. It does approach the horizontal axis but never touches it. And the area under the curve does equal 1. It's not mushroom shaped. Okay? If your selected sample, the size n equals 40. So this is the concept. This is the central limit theorem concept. This is the last part of chapter 6. The last part of chapter 6, we had the central limit theorem, and we were trying to find probabilities of X bar, less than something, greater than something, between something. This is the central limit theorem. In order to work a problem at the last part of chapter 6, there either the population was normal, if the population was normal, then it doesn't matter the size of n, we could work the problem, or n was greater than or equal to 30. So this is how we even asked. There was one example in the chapter 6 notes that said you can't work this problem. Okay? So these are the conditions to be able to work a problem if the population is normal and or n is greater than or equal to 30, then our x bar distribution is approximately normal, and it has a mean x bar equal to the original population mean, and its standard deviation is smaller by sigma divided by the square root of n. So that's the central limit theorem. People are still talking now. That's the central limit. Those are the conditions. That's what this multiple choice question's about. So if in this question it says, if selecting samples of size n equals 40 from a population with a known mean and standard deviation, what requirement, if any, must be satisfied to assume the distribution of sample means is approximately normal? So either the population was normal, it didn't say the population was normal here, or n was greater or equal to 30. Well, because n is 40, n is greater than or equal to 30, we can work the problem, and there's no other conditions. You don't need the population to be normal. It didn't say the population was normal, so the population was not normal here. It didn't say that it was normal. It would have to say it's normal, but here we had n was greater than or equal to 30, so x bar will be approximately normal. That's okay. And then we had a special name for the standard deviation of the population divided by the square root of n. It was called the standard error of the mean. And what's the best point estimate for mu? You know, this is chapter 7 question. We don't know mu. It's going to be x bar. What's the best point estimate for p? It's going to be p hat. It's going to be the sample mean and the sample proportion for these. All right. Okay, so those are concepts. Find the critical value. The population standard deviation is known for an 85% confidence interval. This is the first part of chapter 7, or no, actually this is the very end of it, where I said you could find the critical value if the population standard deviation is known. That's a z critical value, is the absolute value of inverse norm of alpha over 2. Our C is 85% or 0.85. So our alpha is 1 minus C. Here's a picture. Our confidence level is always right in the center, 0.85. And this area is alpha over 2. This area is alpha over 2. Because our confidence level plus our alpha, significance level, will add up. So alpha is 1 minus C is 1 minus 0.85 is 0.15. Alpha over 2 is 0.15 divided by 2. And that's 0.075. Okay, so I think last semester, my classes used a 3x5 note card, and to be honest with you. So you want to do that? Does the class want to use a note card on this test?
Yes.
Oh, you don't? Really? I'm saying this to be free. Okay, you can use a note card. So put this formula on your note card. So you can use a 3x5 handwritten note card. You'll have the formula sheet and a 3x5 handwritten note card. What if you can't afford to buy any note cards? Just take a piece of paper and cut it about 3x5 inches. I don't care. Okay? So you probably want to write this formula on your note card. So you can have a 3x5 inch note card. Handwritten, both sides. You can write on both sides. And no restrictions on what you put on your note card. You can put symbols, whatever you want. I'm not going to look at it. Okay. All right. So we do this in the calculator. All right. So second distribution, inverse norm of 0.075, right? And remember, you have to take the absolute value, so the two decimal places is 1.44. So the answer is 1.44. Okay, so that's only worth 2 points, but you can put that on your note card. Find the critical value if population standard deviation is not known. This means it's a t distribution. And to find the critical value for this, we had to find our degrees of freedom is n minus 1. So to tell you that n is 20. 20 minus 1 is 19. All right. And we had a table. Let's see if I can find that. Or you could use your calculator if it did this. But there were 2 ways. It's the end of the chapter 7 note. Let's see if I have that. I think I printed it out. Or we can pull it up. Oh, here's the positive z-scores. Here it is. So I'll give you the positive z-scores paper, but we're not going to use that for this problem. The negative z-scores if you want it, and the t distribution and the formula sheet. And you can bring a note card too. So when it's a t distribution, that for a mean, that's when we don't know sigma. We find the degrees of freedom, and we find our alpha. This is to use the table. Alpha is 1 minus c. 1 minus 0.9 is 0.10. And it's two-tailed. Confidence intervals are always two-tailed. So we look, area in two tails is 0.10. The degrees of freedom was 19, so I have to go down to 19. And it's always going to be a positive number for this chapter, 1.729. T alpha over 2 is 1.729. I got that from the table. You want to use the table? You can use the table. If you want to use your calculator, some calculators don't have inverse t. It's actually, do you want to see how to use it on the calculator again? Do you guys have it on your calculator? Or do you like this way? Yes. Like this way? You're going to get the table, you just do it this way. I showed you, you can look back at the notes. Okay, so which of the following is not a property of the t distribution? The t distribution is still bell-shaped and symmetric about the mean. that total area under any distribution equals 1. It's not a normal distribution, not a property. The mean, median, mode are all 0. And then degrees of freedom, df, is n minus 1. So, degrees of freedom, you use that for a t distribution. Okay, and then I have the chapter 6 questions. And I say use probability notation, round your probabilities to 4 decimal places, round z to 2 decimal places, label and shade the normal distribution curve for all problems, show all work. So don't, okay, actually on this problem I didn't put the curve for this one, but I have a problem like this. So you don't just give me an answer, you're going to miss most of your points. So, SAT scores have a mean now, so this is chapter 6. In chapter 6, we were given, at the beginning anyway, mu and sigma. And we were told if it was approximately normal. So, this should say that the scores are normal. But SAT scores have a mean of 1,000, so mu for the SAT equals 1,000, standard deviation of 100. ACT scores have a mean of 20 and a standard deviation of 5. A student takes both tests and scores 1130 on the SAT and 28 on the ACT. Which test, find the Z scores for both tests. So this is a formula, it's on the formula sheet. Z equals X minus mu over sigma. So you're going to find the Z score for the SAT. It's going to be 1130 minus 1,000 divided by 100 is 130 divided by 100 is 1.3. I have the, and if you do this on your calculator, minus 1,000 divided by 100. You have to either use parentheses or do the numerator first. You get 1.3. And what do you get for this one? Z equals 28 minus 20 divided by 5. That's 8 over 5 is 1.6. So you better answer the question, which test did they score better on? Here's the two Z scores, 1.6 and 1.3. So the student scored better on the ACT. Okay, and I didn't make you fill out, I don't have a curve for that one. I have it in the sample test, but if you want, you can fill out the curve and make sure your answers make sense, but you don't have to. I don't put a curve on this one. You're not required to draw the picture on this problem on the test. But I have a very similar question on the test. Okay. Find the probability that Z, the standard normal curve, is less than, so Z is less than 1.68. That's your probability notation. And then since it's a standard normal curve, you're going to mark your curve off, Z in the 0 in the center. This is 1, this is 2, 3 is over here. Minus 1, minus 2, minus 3. On these curves, these are 1 and 2, so don't try to make, these are supposed to be 1 standard deviation, 2 standard deviation, okay? Don't add more marks. This is Z, less than 1.68, so it would be here, 1.68. This is labeling, this is shading. You shade to the left, because it's less than. You're gonna go from minus 1,000 to 1.68. So that's normal CDF minus 1,000 to 1.68. Second distribution, normal CDF. Use the negative sign, not the subtraction sign. Negative 1,000, comma, 1.68. And go to 4 places. This is a probability, 0.9535. So this is all part of your answer, is showing those steps. And the notation. Okay? And maybe I don't have time to work every one of these out by hand. So, does that make sense? Alright, let's see what else we have here. Okay, now, on the test, I am not doing 3 of each kind. So, we can skip these. All you do is put in negative 0.14 to 1,000, shade and label it. This is Z. I've got the solution posted, right? This is just like what we just did, except it's greater than. Does anybody need to see these? Okay. All right. Now on number 17, so the test is going to be shorter than this practice test, because I'm not going to test you on three questions on the same thing. Okay, this is giving you an area of 10%. A percentage is probably an area. The lifespan for a brand of tires is normally distributed with a mean of 48,500 miles and a standard deviation of 5,000. If the manufacturer is willing to replace no more than 10%, the 10%, what would be the approximate number of miles for the warranty? 10% will be an area on the left side. They're not going to put it up on the right side and replace all those tires. They want it down here, 0.10. We've got to find our X. I let you use the shortcuts for this. Here we're given an area, we want to find an X. It's X equals inverse norm of the area to the left, which is 0.10, comma, the mean of X, 48,500, I won't put the extra comma there, and the standard deviation of X. So, and you could put 48,500 here, but, and add 500 going up, subtract 500 going down, or write it in thousands if you want. But, here's how you find that. That's one step. Second distribution, inverse norm, 0.10, comma, 48,500, comma, 500. Is anybody checking me to see I'm making? No, I didn't bring the answers. But I probably drew my line a little bit in the wrong place, but it's 47,859 miles. 48,500. This would be 48,000. No, I drew the line in the right place. This would be 47.5. So that makes sense. So if you're given an area, told it's normal, given a mean and standard deviation, you can use inverse norm, and you can use it directly. Okay? Just remember, this is the area to the left, and this is the mean of x, standard deviation of x. Okay? And then, I don't have a bunch of, this is an example similar, but middle 80%. I didn't ask, I'm just gonna ask one problem where you're doing an area. You can look at the answer to this one. I'm gonna cross it out because I'm gonna tell you I didn't do the middle whatever percent. Okay. Okay, and now these are finding probabilities of X. So, an airline knows that the number of suitcases get lost each week is approximately normal with a mean of 15.5 and a standard deviation of 3.6. What's the probability during 1 week that the airline will lose between 10 and 20 suitcases? That's the probability notation. We shade and label our curve 15.5, and we add 3.6 going up, 19.1, and then add another 3.6, so 22.7. 26.3. This is our X. Subtract from 15.5, subtract the standard deviation, 3.6, 11.9, subtract another 3.6, 8.3, and subtract 3.6 to get the third. 4.7. So, between 10 and 20, shade the middle, that's middle, and it is normal CDF. The lower limit is 10, the upper limit is 20, the mean is 15.5, and the standard deviation is 3.6. So we got 10, so we put that in there, second distribution, normal CDF, 10, comma 20, comma 15.5, comma 3.6. So I let you use a shortcut. In my stat lab, it actually tries to get you to convert to Z all the time. You don't need to do that in my stat lab either. It'll count the answer right if you use the shortcut. The shortcut is the lower limit of X, the upper limit of X, the mean of X, the standard deviation of X. We go to 4 places, 0.8311. That's our answer. But I'm looking for probability notations, labeling the curve, shading. So it's your answers is not just your answer. Okay, here's another, this is a different type of question. This is still chapter 6, but it's at the end of the chapter. It says the average number of pounds of red meat a person consumes each year is 196. So that's our mu is 196 with a standard deviation sigma of 22 pounds. This is chapter 6. So we're given the mean and we're given the population stuff. Now it says if a sample of 50, it didn't say this was normal, so this was not normal. Now it says if a sample of 50, n is 50, find the probability that the mean of the sample So we're looking for probability that x bar is less than 200. Will be less than 200. So we need to label the curve for x bar, not x, and we need to find our new standard deviation first. Our new standard deviation is sigma divided by the square root of n, is 22 divided by the square root of 50. There's 50. N was 50. Don't make that mistake. Okay. 22 divided by square root of 50. And keep 4 decimal places, but for our picture we can just use 3. So it's approximately 3.1113. We're going to use that in our calculator. But for the picture, you do need to mark off the picture. So instead of the standard deviation being 22, it's now about 3. So the mean is at 196. It stays the same, but we add 3. We're going to add 3 going up, 199, 202, 205. Subtract 3 going down. Less than 200 is here. We shade below. This goes to negative infinity. We're using negative 1,000. It's normal CDF, negative 1,000, comma, 200, comma, 196, comma, 3.1113. You have to use your new standard deviation. That's the other type of problem from chapter 6. Second distribution, normal CDF, negative 1,000, comma, 200, comma, 196, comma, 3.1113. And we get 0.9007. And we look at where we shade, how much we shaded of the curve, and that makes sense. Questions? Okay, so the next question is exactly similar, very similar. Since it's between, and you have to, your n is 36. So when you're given an n, that's not 1. When you have a sample size. You find your new standard deviation first, mark your curve off for x bar. And that's 15 divided by 30, square root of 36, 15 over 6. 2.5, it came out exactly to 2.5. So you're looking for, I wasn't going to do this one, probability x bar between, 268 x bar and 270. You mark your curve off, you make, it's a mean of 268, and a standard deviation, you have to use 2.5 there, 273. So between 268 and 270 is this little area. It should be less than 30.34. It's going to be normal CDF. The lower limit, the upper limit, the mean was 268, and the standard deviation, the new one, is 2.5. And it should be less than 0.34, because So second distribution, normal CDF, 268, comma, 270, comma, 268. Why are we putting 268 in again? Because that's the mean. 0.2881, and that makes sense because it's less than 0.34. Half of 68% was 0.34. All right, and now we're on chapter 7. So half the test is chapter 6, half is chapter 7. So this is all posted online too. Are you done? Yeah. Okay. Okay, so in chapter 7, so the test is in order. It has the multiple choice, which is chapter 6 and 7 mixed. Okay. Then it has chapter 6 with all those curves. Then it has chapter 7. So in chapter 6, you put your chapter 6 hat on, you're given population means and standard deviation. Chapter 7, you put your chapter 7 hat on, you're not given population means and standard deviation. You're trying to find those. Sometimes you're given a population standard deviation. So here's, we're going to label all your confidence intervals, critical values, margin of error, sample sizes, point estimates with the correct symbol. List all proportions as decimals to 3 places, round z-scores to 2 decimal places. Show the formula or calculator command used. So, here it is. If you're given a confidence interval for proportion, can you find the point estimate? The symbol for sample proportion is p hat, and that's just the upper plus the lower divided by 2. It's just 0.754 plus 0.896 divided by 2. And you can do that in your calculator. Most common mistake is forgetting to divide by 2. So you should get something like 1.5. You should get, and you divide that by 2.75. So let's see. 0.754 plus 0.896 divided by 2. 0.825, and that makes sense. 0.825. Margin of error, the symbol is capital E. That's going to be your upper minus your lower divided by 2. 0.896 minus 0.754, and then we're going to divide by 2. .071. All right, and then some problems. In a random sample of 26 computers, so n is 26, the mean repair cost, so that's our x bar because that's a sample, is 150 with a standard deviation of 36. That's S. It's talking about the sample here. It's a sample, so that's S. Assume the cost of computers is normally distributed so we can work this problem. Okay. Find a point estimate for the population mean cost. X bar equals 150. Find the maximum error of the estimate. That's E, but you're going to find this first. Find your 95%. So this is a confidence interval on a mean. We don't know sigma, we only know S, so we do a T interval. So you go in and put these in your T interval. We have statistics now and not data, so we select that. We put in our X bar was 150. We put in our S is 36. We put in our N was 26. Our confidence level was 95. And then we hit calculate. Okay? Calculate, so it's 135.46 less than mu less than 164.54. Now because I'm running out of time, you're going to write this out. We are 95% confident, etc. But you have to write that out. I have the answers posted. All right, the next one. A survey of 600 non-fatal accidents showed that 21% involved the use of a cell phone. So N is 600. This is P hat. No, this is P hat. It's a survey. It's P hat. Find a point estimate for the population proportion. So P hat is 21% or 0.21. Construct a 99% confidence interval. So it's a proportion. So you're going to use one prop Z interval. C is going to be 99%. But you have to find X. X is N times P hat as a decimal. So it's 600 times 0.21. And you need to round to the nearest whole number. X has to be a whole number. Okay, so 600 times 0.21, and that ended up being a whole number. Probably won't work that way on the test. 126. It's the nearest whole number, and you don't always go up on this one. So X is 126, N is 600, 99%. So go into stat, test, all the way down to A, one proportion Z interval, and put in 126, 600, 99%, right? Calculate. And it comes right back and it tells you this is for a proportion, so it's P 0.167 and 0.253. You're going to interpret your interval. We're 99% confident that the proportion of car accidents that involve cell phone use is between 16.7% and 25.3%. Find the margin of error. Don't use a formula now. It's going to be the upper minus the lower divided by 2. 0.253. We don't have to use any formulas on this stuff, this part. So you're just going to subtract those and remember to divide by 0.167 divided by 2. Make sure your answer makes sense. 0.043. All right, and the answers are all posted. So for proportions, sometimes we're given X and N, and sometimes we're given P hat and N, and we have to find X. X will always be smaller than N. And is this the last page? Yes. So let's make sure we look at this, because a lot of people get to these problems on the test and they say, I have no idea how to do this. We didn't cover this. What the heck? We didn't cover this. Yes, we did. So this is asking for sample size. How large a sample should she select if she wants to be 95% confident? that the true mean is within 3 ounces, so our E is 3. Assume the standard deviation of birth weights is known to be 7. So, sample size, here they are on our formula sheet. Sample size determination. For a mean, you're going to use this formula. N equals the critical value times sigma divided by E squared. So, I'm going to write it up here. N equals the critical value for a confidence interval times sigma divided by E squared. So we look up our critical value for 95%. It's on the positive z-scores table that I give you. It's one of those common confidence levels. For 90%, you have to use 3 decimal places. The critical value is 1.645. So z alpha over 2 is from the table 1.645. You don't have to do inverse norm on that. Just look it up in the table. So n is 1.645 times 7 divided by 3. It didn't say 3%, so it's just 3. And we're going to square that. Don't forget to square it. Okay? So we can put it in the calculator just like that with parentheses if we want. 1.645 times 7 divided by 3, close the parenthesis, and square that. If we get 14.7 something, so you go up to 15. You'd have to use a sample size of 15, and what's the next one? It's a finding sample size for proportions. So there it is. Here's the formulas. If we don't have an estimate for p hat, we're going to use this one. If we do have an estimate for p hat, we're going to use this one. So the formula is n. On this one, we don't know p hat, so we're going to use 0.25 times the critical value divided by E squared. Okay, so how large a sample is needed to be 99% confident? So with a 99% confidence interval, our critical value, you look it up in the table, is 2.575. This is the positive z-scores table. 2.575. Sorry. And it says that we need to make sure it doesn't differ from the population proportion by more than 3%. Our E is 3%. We have to change that to a decimal, which is 0.03. Change it correctly to a decimal. So it's 0.25 times 2.575 divided by 0.03 squared. You'll put that in your calculator, get an answer. If you get any decimal at all, you go up to the next whole number. The next one, repeat part A, assuming that previous studies found 80%. This is our p hat, is 0.80. That means q hat is 1 minus 0.80 is 0.20. So we have a p hat, so it's p hat times q hat times the critical value divided by E squared. We're going to use, those stay the same. We're going to use 0.8 times 0.20 times 2.575 divided by 0.03 squared. And you can look at the answers. We'll get a number. If it has a decimal, we'll go up to the next whole number. And then on this last one, the way you do it, it's data, just like with the bunny computations. We put this data in our list 1. It's a test on a mean. we don't know sigma, so we're gonna do a T interval with data. And the point estimate is gonna be X bar, whatever it gives us when we do our T interval. Interpret our interval, find E. Find your interval first. Just like we put it in our list and we chose data. Leave the frequency at 1. You got the answers posted to these. But thank you guys. Let me know if you have any questions. Have a good day. So you can have a note card.